All right, let's dive right into this explainer. Today, we're unpacking the modern geopolitical and financial realities behind what is honestly one of the most fascinating materials trades of the decade. We are looking at a situation where the entire future of global air dominance might literally hinge on dirt from a project in rural Nebraska. So let's decode this incredibly intricate relationship between a critical aerospace material, massive defense contracts, and the multi-million-dollar hurdles required to actually pull the whole shebang off.
You know, this headline really hits the nail on the head. Lockheed just bet on a metal almost no one's heard of. It perfectly captures that crazy tension between a totally obscure commodity and a massive national security imperative. I mean, most of us know about lithium, copper, or rare earths, right? But scandium? It pretty much flies completely under the radar. Yet, when one of the premier defense contractors on the planet makes a public move to secure this specific material, it tells us a major paradigm shift is happening in aerospace manufacturing.
And wow, the market definitely noticed. When Lockheed Martin signed a 10-year supply agreement with a relatively small critical minerals developer called NioCorp stock shot up 16% in a single day. That is a massive market catalyst. It shows us that investors instantly recognized the huge implications of connecting an absolute aerospace titan with a domestic source of a highly specialized material.
Section 1. The Lockheed Bet, a critical defense move.
To really understand this bet, you have to understand the exact amount of commercial scandium currently mined in the United States. Zero. Nothing. We have absolutely no domestic commercial production. For a material that is suddenly becoming the linchpin for next-generation defense platforms, relying entirely on foreign powers is just an immense national security vulnerability. So that massive vulnerability is exactly why this Memorandum of Understanding is such a big deal. Lockheed is eyeing up to 15 tons of scandium oxide, or its equivalent in advanced alloys, every single year for a decade from NioCorp's Elk Creek Project. Now, keep in mind, a non-binding MOU is basically a corporate handshake, so it's just the first step. But it signals to the broader market that the demand is real, provided the physical supply chain can actually be built.
Section 2. Why aerospace needs it. The magic of scandium. So why are defense primes so incredibly desperate to get their hands on this stuff? Well, think of scandium as an absolute steroid for aluminum. When you add even a tiny amount of it, sometimes just 0.2%, it completely changes the metallurgical game. It forms these nanoscale structures called coherent Al3SC precipitates. Simply put, these act like microscopic anchors. They pin the internal structure of the aluminum in place so it doesn't deform or weaken even under extreme heat and stress. It's really fascinating.
The contrast in manufacturing here is just staggering. Conventional aerospace aluminum requires heavy mechanical fastening. We're talking thousands of heavy rivets because the heat of welding actually destroys the metal strength. But by adding scandium, the alloy sees a 40 to 60% increase in strength. And, crucially, it becomes fully weldable while staying incredibly stable up to 350 degrees Celsius. Aerospace engineers can eliminate all those rivets and even replace much heavier titanium parts.
When you have yield strengths exceeding 450 megapascals, which basically means the metal can withstand tens of thousands of pounds of pressure per square inch, you unlock a 15 to 25% structural weight reduction in the aircraft. Lighter, stronger jets that don't need expensive riveting can fly further, burn way less fuel, and carry heavier weapon payloads. Plus, it's highly compatible with 3D printing for rapid manufacturing. For aerial combat, this is basically the holy grail. Section 3. The NGAD Fighter Race, Next-Gen Air Dominance. Washington has actually been preparing for this materials arms race since DARPA launched the Air Dominance Initiative back in 2014. But lately, the urgency has violently spiked. In late 2024, China revealed their J-36 tailless stealth aircraft prototype. In direct response to that, the U.S. is aggressively pushing its next-generation air dominance, or NGAD program, and they recently selected Boeing to build the massive F-47 manned fighter. And here's the kicker. These sixth-generation fighters require the exact thermal and weight properties that scandium provides. But here is where we hit a massive bottleneck. Scandium isn't mined directly. It's exclusively recovered as a byproduct of processing other metals, things like titanium, uranium, cobalt, and nickel laterites. Because of this, the total global supply is tied entirely to the economics of those other commodity markets. And right now, the processing and supply of these critical minerals is an entire chain almost completely choked by Chinese market dominance.
The U.S. government sees this vulnerability loud and clear. That's why the Pentagon stepped in with a $10 million grant under Title III of the Defense Production Act. It's undeniable proof of Washington's urgency. They realize they simply cannot confidently build the F-47 or the fleets of autonomous drones that'll fly alongside it without breaking that monopoly on raw materials. So they are actively funding the effort to figure out how to pull this critical metal right out of the American Midwest.
The ultimate vision here is a totally localized, domestic mine-to-warfighter pipeline. Step 1. Dig up the ore at the Elk Creek mine in Nebraska. Step 2. Extract high-purity scandium oxide. Step 3. Produce the aluminum-scandium master alloy, which NioCorp is actually already working on in pilot phases. And finally, Step 4. Get that material straight into the fuselages of America's most advanced stealth fighters, built by Boeing and Lockheed Martin.
Section 4. Financing the reality. Capital for Elk Creek.
Okay, time for a bit of a reality check on this trade. NioCorp has some amazing geopolitical tailwinds behind them. They've got that 10-year MOU with Lockheed, a DoD grant, and a market desperately hungry for critical minerals. But they still have to navigate some pretty severe hurdles. To actually build the Elk Creek project, they need massive final debt financing, potentially from the U.S. Export-Import Bank. They're also relying on a standby equity purchase agreement with the Yorkville Investment Fund to inject cash. The capital expenditure required to just get this out of the ground is absolutely immense. The stakes for securing this funding couldn't be higher. If NioCorp can finalize the financing and actually get the facility built, Elk Creek will become the beating heart of America's advanced aerospace materials sector. They're targeting a massive production goal of approximately 100 tons of scandium oxide annually. To put that into perspective, considering the U.S. currently produces 0, that single volume would completely transform the domestic supply chain literally overnight. Which leaves us with this final thought. We have the aerospace technology, we have the desperate demand, and we literally have the raw ore sitting beneath the dirt in Nebraska. When national security is on the line, when next-generation fighters like the F-47 are at stake, and when the current supply chain is totally dominated by a strategic competitor, will geopolitical necessities simply force this Elk Creek financing through? It's a fascinating intersection of underground metallurgy and global defense. And for sure, it's a story we'll be watching very closely. Thank you for joining me on this explainer. I really hope you found this breakdown as fascinating as I did.